Welcome to the Program Memory course of the HT8 MCU Basic Tutorial. This course will take you through the program memory of the HT8 MCU from the following four aspects: Memory Introduction, Program Memory Introduction, Program Memory Structure, and Lookup Table Example. Memory Introduction. What is a memory? It is a memory in the device and used to store user programs, data, and other content. What are the types of memory? They are mainly divided into three categories: ROM, RAM, and EEPROM. The full name of ROM is read-only memory, which is used to store user programs and can only be read. The data retains even when its power supply is removed. The full name of RAM is random access memory, which is used to store temporary information and can be read and written an infinite number of times, but the data will be lost when its power supply is removed. The full name of EEPROM is electrically erasable programmable read-only memory, which is used to store product identification numbers, calibration values, and other user-programmed content. It can be read an infinite of times, but the number of writes is limited. The data retains even when its power supply is removed. Program Memory Introduction. What is a program memory? It is used to store user programs, which includes special vectors, data tables, and other programs. Special vectors typically include initialization vector and interrupt vectors. The data in the program memory remains even when its power supply is removed. During the program execution, the data does not change. The HT8 MCU program memory is divided into two areas: special vectors, data tables, and other programs. Program memory can be divided into three categories: mask ROM, OTP ROM, and flash memory. What are the differences among mask ROM, OTP ROM, and flash memory? Mask ROM is the cheapest, the program already fixed at the time of manufacture and cannot be erased. It is suitable for products where the program does not change. Currently, its market demand is already very low. OTP ROM is relatively more expensive than mask ROM, allowing users to program once. It is suitable for products with minimal program changes. Currently, its market demand is average. Flash memory is relatively more expensive, allowing users to repeatedly erase and program. It is suitable for products with flexible program changes or for product development. Currently, it is the mainstream in the market and its market demand is highest. Program memory structure. The following will take the HT66F3195 as an example to introduce the program memory structure. For the device, the program memory is flash type, which has a capacity of 8 kilo multiplied by 16 bits. As shown in the figure, the location hex 0000 is reserved for the initialization vector. After a device reset is initiated, the program will jump to this location and begin execution. The locations from hex 0004 to hex 002C are reserved for the interrupt vectors. If the device responds to an interrupt, it will jump to the corresponding address and begin executing. Besides the special vectors mentioned above, other addresses in the program memory can be defined as data tables or used to store other programs. Lookup table example. Firstly, let's understand what a lookup table is. A lookup table is the process of reading data tables which the user has stored in the program memory. Let's learn the common methods of defining constants before applying the example descriptions. How to define constants? There are two common methods. The first method is to define a constant named data1. Its address is automatically assigned by the compiler. The advantage of this method is that it simplifies development and ensures the portability of the program. The second method is to define a constant named data2 and assign it to a specific address. This method is mainly used for specific memory allocation, etc. How to define a constant array? The first method is to define a constant array named array1. Its address is automatically assigned by the compiler. The second method is to define a constant array named array2 and assign it to a specific address. Below is a simple example to demonstrate how to perform a lookup table operation. First, a table needs to be created. At address hex 0200, define a data table. And store the encoding table for displaying the digits 0 to 9 on a common cathode digital tube. Let's take a look at a code example. First, fill in the storage starting address. Next, fill in the number of data. Then, store the data content in sequence. How to perform a lookup table to read and use the data. After the data table is created. How to read out the fourth data in array 1. First, let's define a variable named variable1. Then, set variable 1 to the fourth element of array 1 to read the data. It should be noted that arrays are indexed starting from 0, so the index of the fourth data is 3. Course summary. In this course, we have learned about memory and program memory. You will have a clear understanding of the program memory. Holtec has a professional service team to assist in development design and after-sales service. Please feel free to contact our business departments for more detailed product information and consultation services.